Okay, for today's our smart security, and then today we will introduce one more on the IoT security smart things. We'll be using blockchain. Okay, so before we go into the blockchain, so we maybe introduce what is the blockchain, and then how can those the distributed ledger technology. So we need to have a basic understanding what is the blockchain technology. Okay, and then we will show us an overview. How can like using the blockchain will be different from using traditional database. Just like maybe not really like the RDMS, the relational database, or even the NoSQL. Okay, and what's the possible use case application we're going to apply? Okay, and what the commonality security challenge and how those project get able to address it. Okay, and then maybe possibly what kind of real world examples can the blockchain application in IoT networks. Okay, and also some like smart contracts for the IoT automation. So we can introduce some like smart contracts, and then how can make the IoT process like web update and have them connect each other so they can create contracts. And then how can we enhance the IoT security? So make it the efficiency through the automated contracts execution of this, and then also show you like if you want to using the blockchain. Okay, how can we do that? Like cover in the last part. If you're interested, you can try to follow and look at it. And as a beginning, so we know like blockchain is decentralized and then distributed technology, so they can like secured records, all those like transactions across the network computers. So all those nodes, okay, and they can operate without a central authority. And also we can ensure the right transparency, immutability, and data integrity. But here's one thing when we talk about the without a central authority, because if you're the peers, okay, of course there's one more we have we got the but also we can recognize certain nodes like they are authorized. Okay, so those that we already know those nodes, also they're possible to form the blockchain. Okay, so for this one, we dive slightly deeper in the future, or if you know. And I want to show one page is like from the next, and I see. So this one also give you some basic diagrams, right, showing like how the blockchain looks like. So we say it's a block, right? So within the block, including like some hash and then timestamp, okay, and then also some transaction lists, okay. So they create different blocks, okay, and all those blocks will connect to the chain. So this one is the chain. So that's why we call it like blockchain, okay. Let me switch back to blockchain, okay. And when we go deeper, we say the decentralization. So what's the decentralization? So unlike those like centralized system blockchain, we are not really rely on one single entity. So it can spread across many participants. So we say different nodes, right? And in the network. So the advantage it can help us to reduce the risk associated with the central point of failure. So in case one node fail, we can still able to access for other nodes, okay? And immutability. So let's say if we have one block add to this chain, so it can not be altered. So we can alter it, and we can achieve it by using the cryptographic hash. Okay, different type of cryptography. So we can then we can link each block to the previous one. Okay, so then we can add a dot one new block. Okay, add it to the chain. And also one thing is about transparency. So so all the participants they can access the blockchain like history. So you will see like we have the transaction list, and we can ensure the visibility and trust in the transaction so that we know okay what we can. And also one thing, why is like we talk about security. So all these transactions, they were encrypted using cryptographic algorithm, and they have that conscience mechanism so to validate that. So this way we can ensure that no like single participant can manipulate the system they enter. But for other nodes, they will when you check, okay, so let's say maybe in centralized system when you modify the content, they will say, okay, so that one is the fake content. Oh, okay. But in the blockchain, even you change your own, but you cannot change others' nodes. Okay, so that means they when they try to validate, compare, then they will see they can tell you is not correct. Okay, so that's why it can enhance the security. As a block, I'm showing, so including the block, I give you a graph. So those blocks will is a collection of all the transaction or the data, including the timestamp. Also, they have their unique cryptographic hash. Okay, and also they will increase the reference. So also it's the hash too. So to the previous block. Okay, so it can format a chain. So like this, and in each block, so you connect the header. So those that header also increase the timestamp as well hash of the previous block. So this will be the header, and then the block body so will be the transaction data. So including inside. Okay, and then the Merkle root. So those will be the cryptographic hash. So those hash will summarize all the transaction in the block. So all these will included. And we try to form the blockchain. So like after we have all these blocks, and then the core components of those blockchain, we say the nodes. Okay. We sometimes we using say nodes will be the computer or some devices that like they participate in this blockchain network. So they can maintain the copy so of distribution. Okay. So those nodes will be try to validate and store the data and communicate to each other with each other's. So we call formatting. If we have a full node, so that means it will store the complete history of the blockchain. So all them, okay. And if there's some like light node, so in the term light node, we will only store only part of the blockchain. So maybe they will rely on some like full node for the data verification, okay. And they will be two more types nodes. So it's showing. And about the consensus, the mechanism. So for the mechanism, it include involve the algorithm. So all these algorithm can help us to ensure all these nodes they agree on the volatilities of the transactions. So they do not really like require any more like central authorities. And if you remember in our previous encryption, no matter using the TLS, as I said, we need to like get the certificate from the authority or even you thinking really simple login password. So whether it's a account user. So you can treat it like this. So there are some if once we using the all other nodes to check your availabilities, okay, then you do not require it. Okay, anybody can do that. And we do have some popular mechanism using it. So one is called a proof of work buildable, and it's the miner. So those that miner will solve a complex mathematical problems. So to add a new block, okay. This one is pretty common if you because you know they use the blockchain for those like Bitcoin, other different type of coins. So they will joining in this way. They will solve the complex mathematical problems. Okay, and also they can do in another way. It's called proof of stack. Okay, stack. So with a POS, so they can stack those the tokens. So they have a chance to validate the transaction. So this is another part of it. So this one we using blockchain to maybe the we say the blockchain wallet. So can be using for those token, and then we say we also can like providing another delegate proof of a stack. So that one's a DPoS will be a small group of trust nodes. So those will be validate the transaction. So you see right here. So sometimes we have some trust. We already have we can know it's still not yet centralized, but we will like for some nodes that we think okay is a trustable. Okay. And another part will be the cryptographic because we talk about the hashing using hashing everywhere. So all those all the blocks, so they will contain a unique hash. They will generate from the transaction data. So in case any data in a block they change, then the hash will also change. So it can allows the ensure one thing of the tamper resistance. So you know tamper because they try to like put something whatever put on top. And if for Bitcoin, you see we're using SHA 256. So it's one of the example. It can help to secure the hashing algorithm. And okay, why not we quickly like go through some background like introducing the blockchain. Compared with traditional database, like for our IoT devices, we can think about okay, for their data storage, because the data will distribute across all the different nodes. As we say, we have a full node, maybe have a light one. So if you right here, so we have full node or a light node, so we keep part of it, and then they can go and like to maybe rely on the full nodes to verify the data. So they're all possible. But in our traditional database, we will like keep it centralized in one single database server. If you might be work on already follow all the work, so you will know like Raspberry or like on device camera. So after they capture the data, they will send it through the gateway to the server. They will save all the data, maybe the videos, numbers, all those related maybe temperature, sensor information. Okay, all these links. So it will cause a, of course, like you can imagine if we have a centralized database server. So in case you have some crash, people like modify. So we'll talk about some security things, but you know, it's an issue. And for security, so it's like immutable. The reason for also is it does have a tamper resistant. The reason it's immutable because you know we involve different nodes. So you cannot say, okay, let me change one node's data because you need to like compare where they or like if you're tampering, you will say that because once the data change, we have different hash. So we can compare it. But for trans data, once I able to, if there's some numericity, so the data breaches, then if I change your login password data, some data information, camera information, or this maybe your smart home information or these things data, then it's easy to change it. Okay, and for the control, so we because we don't have a really central authority, so we can do the decentralization. But for the traditional database, so no matter NoSQL or like MongoDB or others like RMDS like MySQL or some DB whatever, so they have centralized control. So controlled by the admin, some user account, and so far, because the blockchain we can like open for the public or like some like permission, okay, auditable, okay. So because all those nodes we involve, okay, and for our database, sometimes we just keep it private or like our hosting on our own server, so kind of we have limited visibility, okay, and but here will be a top trade of the performance because we will getting slightly slower because the protocols, the consensus protocols. So when we talk about like all those like protocol right here, um, because we have the mechanism including like let's say we're using the proof of work or proof of stake, so different tokens or like smaller group delegated to like so all this will cause the performance lower and it was slightly faster. So if we even for a large scale transactions because we have centralized and just log in, okay. And so far for the availability, so if you remember like CIA Okay, A is the availability, so we can make sure that it's being like highly available. So due to the application, because we have multiple nodes involved, so even one is done, we can have other nodes like help to serve it. Okay, but this one will be depends on your server. But you say let's say we have using the CDN, and then or I can use the load balancing and then have a distributed different server, but it will kind of like but also all the content will be kept in the centralized server. Like you are impossible like compare with blockchain and regular server. Of course, the nodes involved in the blockchain will be more than what you expect. Okay. So okay, try to summarize the advantage. So one thing we can eliminate the need of intermediates, so we can reduce the fraud. Also, we can increase the transparency, so we can allow all the participants so to like independently verify the data. Okay, so that's the advantage to enhance the security. And so far in our then how can we fit? Because this one may be slightly go back to what we covered in our previous lectures. We always talk about like IoT security challenge. Okay, so for the data authentication, so all those devices maybe they don't have a strong the lack of it. Okay, strong authentication mechanism, so they're easy like make them vulnerable for like impersonation like attacks and integrity because they always generate large amount of data, so they can be like manipulated by the attacker. So if without any proper secure way, and then also the communication itself. So how can we ensure some transmission of data being like more secure between IoT device or some? So it would be kind of critical concern. So it's really crucial. How can we secure the transmission of data? So if you remember, we say in transit and at rest. So there will be two parts. We need to solve and to increase the security on it. And also another part will be the centralized point of failure. So there's a lot of IoT system actually since we rely on a centralized server or like we are like posting to a cloud system. So in case the most easy like I can use DDoS attack and then cost you like out of resources you cannot respond. That means okay, even my devices is working fine. I can keep sending data because your centralized server cannot respond it. So you cannot save the data, your app cannot respond it. So it causes an issue. And also here's the scalability. Okay, because the IoT network always connect like millions of devices and then going up like if you remember the numbers of protection. Okay, so after later maybe they double of it. So how can we manage that's like huge amount of devices the securities like efficiently? So there's a new direction we can think about it. And so we try to like, fit all those characteristics of the blockchain to like apply to the those like challenge. Okay, so first thing about decentralization. So once we remove the central authorities, so we can like those blockchain can reduce a risk like if any single node or we say the point of failure, then other nodes we can use it for like authorized. Okay, in immutability. So because the blockchain is immutable, so like the legal ensure one thing is like any data they record, they are tamper proof. Okay, different proof if you remember, and then we will provide a reliable source of trust. Okay, so the truth is like they have to change it, and then it's being like transparency one thing. So all the participants they can access to the transaction history, and then they can create an auditable and then the transfer system. Okay, so everything you know who accesses it or which the participant join it. So everything is clean. So you can like check all those previous record. And then the device authentication. So blockchain can secure and then also store the credentials of the IoT devices. So the device, they are registered on the blockchain, so they can using the cryptographic certificate, so they can ensure when things like only some authorized devices can join the network. One thing we can ensure authentication if you let's say we can have the blockchain wallet, if you remember the wallet something, so we can use it for login. So all those that authorized devices we can use it, so they can use it for the saving those like credentials. Okay, we can secure the device. And then the public key infrastructure. So all these like each devices they can be assigned, so they can get their unique public key or private key pair, and those keys stored on the blockchain, so they can for the authentication. So this we can use, and also the decentralized identity management. So we can replace the traditional way, the central identity system. So we can for by managing those IoT devices. We can validate from different participants those nodes. So again, we can see you do know who I am. Just again, so here's my login information. Here's my key. So can you, because those public key they store on those like blockchain. So I can ask, I have my private key. Can match it? Yes, then I can log it like this. And data integrity is say because all those data written directly to the blockchain, then we can ensure like they cannot be like altered. So once they record, and even maybe we have some like man in the middle attack or like they change it later. But after we try to compare or like checking all the transaction history, all the different blocks, and you say, this one all did like tampered, and we can like even change it and say, that one is not a correct one, and data provenance. And like since all the IoT sensors we think they will be come with the timestamp, so and hashed it, so we can ensure the offer statistics of the data and check it like provenance over time. So like you will see like kind of same idea because we have all the transaction list history, and also we can provide some like automated like auditing. So if any tampering with the data, so they can like immediately visible, because since they once they try to like alter the content and the hash will be changed, right, if you remember. So if they will say, they're not matched with the original record. So they will know, so all the things. So we can make it like automatic, so we don't have to validate by ourselves again. And then also compare like more like traditional with the trusted model, because for the we say the blockchain based decentralized it. So for the centralized system, so they rely on the some third party, we say like certificate authority or something like based on the cloud provider. So we try to validate and authorize the transaction or the data exchange. And then this one change the node. And if we try to do it using the blockchain enabled trust, first one is the distributed consensus, and those blockchain we can be relying on the consensus of the multiple decentralized nodes, and then we can validate those like transactions. No single entity have a control of the data. So here's how it looks. Also the cryptographic proof. So we can use those that proof cryptographic proof to ensure their data integrity. So here would be CSCI integrity, and validate those like transition and autonomy. And then the IoT device they can interact with like just one another. So that we rely on the one centralized authority. So these are pretty in ideal for environment for this like where decentralization, when we say crucial, like sometimes we have some remote area or have some dynamic networks. We exchange, we can find and then nodes, and we can doing the validation, and then we can find those trusted nodes using the blockchain. So quickly we go through like have some background introduction of blockchain, and then based on the some vulnerabilities of the IoTs and those security issues, then how can we apply the blockchain then? Possibly, actually, even in IBM, they do mention some actual application like they introduce CSCI. Once in the supply chain checking, they say it's in transportation. Okay, so maybe the kind of future products or sometimes the level of transparency in the supply chain. Okay, so we can use it to check the those like good like every step of the supply chain. If we have the centralized, if we are using traditional model, so maybe we have the IoT device sensor checking like maybe their location, their condition, maybe your sensor, especially some good need to keep in certain temperature condition. Okay, they're sending it. Okay, so in every step of the supply chain, so we can ensure one thing is the authority of the authenticity, and also we can reduce those like fault. Okay, and those sensors attached to the products, they can update the blockchain in real time. So, but also they in distributed like nodes. Okay, so we can ensure the data integrity. And then also like maybe in the smart cities. So when we try to work on the smart city, so let's say we have the security issue, like managing millions of IoT devices in the urban infrastructure, including the traffic lights or some like buildings, sensors, all this. So we can manage first is their identity. So we can use it also like secure their communication, also ensure the real-time data integrity across the network. So especially when we open to public, even it's public, because all this data like keep in the blockchain, then we can maintain. Okay, so we even the hacker like access to this like public shared network or some certain sometimes we say dynamic network. So it's still possible. We can use blockchain, right? And let's say sometimes we see the some health care, so it's like some patients, so it will involve like some patient maybe have a fit band or like their drinking habit, they will always involve their patients like personal information, their data privacy or some like device like temporary. So same way, so we can ensure those like secure and auditable logs. Okay, so they even they've been hacked, those have been fitness been like banned or whatever. And if we trace like those transaction history, and then or even they try to alter those data, but all those are not, as I said, can like validate it, so automated. So also we can keep it in private. Okay, so we can resist that. So it's a good, what do you think? And then we have some like for the industrial. So industrial also we can help for monitoring those like industrial settings. And sometimes we can check the machine performance or some maintenance logs. Also some like alert. So if like some like repair, so there comes some maintenance alert, so it goes share. So if the attackers like they want to change it, like we say, then we can, because since we can maintain the integrity, like it's a proof, so it will be provide better security. Okay. And well, here just think, because we talk about the supply chain, right? So maybe let's say traditionally we have the supply chain in multiple intermediate, so we can create some really complex web of like communication, because we not only updating those like courier, okay, deliver, and then maybe the company like need to ship, and then also the customer they need to check, or maybe there are different warehouse in transition. So it makes all those intermediates like maybe like able to manipulate those data. Okay, so it's really hard to verify, because you never know in which state or like in which like transition or like from different wares are being hacked and then they're being changed out. So it would be good like if we apply the blockchain, we can change all the history and then they have distributed nodes. So here you can see all the products like can be applied for the solution or the products or batch of the product. So we can give them a really unique digital identity. So we can save them stored in the blockchain. Okay. And those IoT sensor like track those environment conditions, including the temperatures, humidity during the transport. So that's what I say. So this one also from the IBM talk about the IoT with the blockchain. They also like taking it as an example and they would recommend suggest it this way. So in each step of the supply chain, once they update the data like with it, and then they can ensure the one thing is the products authoricities, and one thing also the real-time tracking, because for the blockchain they for IoT we come with the timestamp, and then also our blockchain also contain like in the header also contain the timestamp. So all these and so far everything. So we can bring some benefit like including one part is of high transparency. So each transaction like including the shipping, handling, or like some like customers like clearance. So everything will be visible on the blockchain. So the user, no matter user or the courier and or like others like parties involved, they can like check it and traceability, because those consumer especially business can trace all those like product journey, okay, from the manufacturer to end user. So in all the stage, okay, and then they can provide tamper proof. All these like data they record on the blockchain. They since one thing we know the properties that they cannot be altered, so we can ensure okay ensure the authoricities. Okay, and we talk about one thing about the smart contracts, right, for the IoT automation. So what's the smart contracts? So it will be the kind of like self-executing contracts. So with the terms, so they will have some agreement, so they written directly into the code. So once the conditions they are met, then the contract will automatically execute in action. This why is it like comes as benefits? Because we can like reduce the need of intermediaries. Okay, we don't have to send it to certain party approve and agree. So once we just meet all those like conditions they are all made, then we can just generate the content. Okay, so we can make the whole process more like faster and then even more like secure. Now, how can we use like those like smart contracts like being can work? So first, we need to write the condition. So we need to define the terms of the contract. Let's say maybe the temperature sensor they must like be below threshold. So we can set a threshold. So it's impossible like a but of course it depends on which type. Let's say in the transportation, okay, the temperature they kind of like below maybe 100 or like above certain, then they can start. Okay, you can start. And then for the IoT interaction, those IoT devices they can send the real-time data, so the readings to the blockchain. And the contrast execution stage. So if the condition they are met, okay, so they let's say the temperature is below it, then the smart contrast will automatically like perform the action, so they can send alert, trigger the device shut down this signal to the end device or edge computing. So like this. And so far everything it comes like it brings the automations. One thing because we don't have like require the human to have innovated or the operational delay. Let's say if we have to adopt a new device, we can think about if we have a smart contract, and then once we put it in and it can like meet all the conditions. Okay, the environment issue or some network connection, and then we can just like naturally adapt it and then sending the data. So once we have less human intervention, that we can like lower the security risk. Okay, for the that's why for the security. So because things they are running automatically, so he's um good they're doing better in reducing the risk of the fraud or error. And since we don't have to like involve some like humans in it, and it can like brings a better efficiency because the like streamline process, so they can eliminating those like manual steps, so they can like do it by so once they meet the condition, so the contract will be like executed directly. And we can how we can like, improve the IoT securities, based on like automating those response to the various scenario. So maybe like automatically logging or unlocking the IoT devices, those smart things like based on the some security protocols. And also we can like trigger, okay, so we can trigger some security updates. So if there's some like new breaches they are detected, then we can like if we trigger something, then based on our smart contract, we try to fetch some like batch or like can we update something. Also some access to data. So we can based on some predefined conditions. So we can get the contracts that we are allowed to sign in. Okay, and here's one example. If we have the IoT device, so we can maybe it detects intrusion attempt. So we will have a smart contract immediately like trigger. So for our security response, so let's say we can sending alert or shut down the device, or they can terminate the connection word like this. So this one is called a smart contract. Okay. And right here, if we are using using the smart contract where like in the IoT devices integrated. So if let's say we have a fleet of a delivery truck, so they if it connects with IoT sensor, so using for transport like sensitive goods. Okay, and we applying the blockchain and smart contracts, so we can ensure one thing is the data integrity, so we can maintain throughout the whole journey. And also if we trigger some like temperature change or mainly for delivery, maybe from warehouse location to location, like reach certain stage or when they unpack it or based on the condition, then we can send certain alert, or we know, okay, if we have a trusted um, device, and then if we know some company, maybe the customer will know, okay, so like um they deliver to some recognized location, then the smart contract will be limited. Okay, so we know the location, and the customer will receive the notification, even the maybe the system, okay, can get the update. Okay, maybe the sender also can receive the alert. Okay, or in case that somewhere they lost it, okay, if they lost it too, so they will receive all these notice. They're possible. And the logic in behind, so as we say, maybe the temperature or the location data, so they will log on the blockchain, and the smart contract will verify those like data. Okay, so once they match those like predefined threshold, so maybe they have to stay within a certain range. If we need to deliver, let's say the trunk like deliver some like frozen food, so we have the temperature they need to maintain like below maybe certain degree. Okay, or about like not too low or not too high like this. Okay, so in case if the condition valid, so the contract trigger so can be alert. Okay, they can notify some manager. Okay, so if let's say if they need to keep those food, or like let's say they are shipping the vegetables or some fruit. Okay, so if the temperature too high, probably maybe those vegetable like will be go bad. Okay, so maybe in the next start, okay, they have to maybe check it, so they can, those the manager can, like, based on this like smart contracts on it, also blockchain, so they can like receive some notice, they will like trigger it and then send it, then alert automatically. Okay. And so for everything, it will make the smart contracts automate the whole like monitoring condition better, and also it can give a really good response to the deviations. So we can ensure the integrity and security of the delivery process. So for like this. And as of the cover last part, using using the blockchain base for the IoT application. How can we implement it? So if we're interested, so involving one is the Node.js, which is Antivirus, and the incarnations, Solidity, and Web3.js. So it's we you can like install it. Like one is that we need to simulate the Ethernet for the network. Okay, that means that we need to simulate the blockchain, and then we need to write the smart contract. Okay, so and then for the IoT device integrity, and how can we deploy and integrate with the smart contracts using Web3.js. So here's just like some quick instruction, like simple, just telling you, okay, you can install it and then write some code. Like let's say if you receive the temperature sensor, and then how can we create the smart contract. So I'll give you some like more details if we have time, like extra things, then we can try to implement this part, like using the blockchain for your final project. Okay, but of course, like for your final project, as a basic, you need to set up and then build a connection. And just like kindly reminding you, because then coming after I cover the engineering lab, then the new assignment will be available. You need to sending the heartbeat, like sending to your data server, and then save it. Okay. So what kind of like we just like cover was the blockchain for the IoT security. So we mainly the property of the decentralized, and we can maintain the like security integrity also, because it can be more like transparency problem of the IoT system, and we can enable one thing about the authentications, immutables record, and also automate those like process using the smart contracts. Okay, and in the future, I think blockchain will be crucial actually in all other courses. We also how can apply blockchain in other areas. So IoT will be coming together with like combined with the AI, some edge computing, so make it more like fully automated and also like secure the IoT network. And so far, that's it. Thank you so much.